Hi, welcome to my video on review 3 of limits and continuity, and this review is on videos 22 to 32. And as in previous reviews, the total for this review marked as a quiz is 33. So give yourself a mark for each question that we have right and total up the pages and see how you make out. Here we go. Number 1, f of x equals 1 over x minus 2. What values of x is the f of x continuous? Well, we know, or should know, that x minus 2 equals 0, x equals 2. The denominator cannot be equal to 0, so we cannot have a 2. So that means that this is continuous for x is not equal to 2. So all values can work into this function. It's a rational function, and we cannot have 2, so x is not equal to 2. Give yourself a mark. Here we have h of x is continuous at what interval, what point? Is the h of x continuous at -1? -1, yes, is right here. At 0, 0 is a 3, and 1 is a hollow dot, so the answer is it's not continuous at 1. Give yourself a mark if you have 1. State the condition that sums up continuity. The condition that sums up continuity is the limit as x approaches c of the f of x equals the f of c. So the f of c means it's defined. The limit as the f of x as x approaches c on the f of x, this means right here, this part on the left, means that the left side is equal to the right side, so the limit at c from the left and right is the same value. So when these two values here equals the same number, then we have continuity. So if you have this condition, give yourself a mark. Number 4, the d of x is a piecewise function made up of 3 parts, and is asking if the d of x is continuous at 3. So 3 is greater than here, that's to the right. 3 is less than. X is less than 3 is to the left. X is equal to 3 at 5. So is it continuous? So A is, what is the d? Is it continuous at 3? So the d of 3 is equal to 5. So it's defined. The B part is that the limit of the d of x as x approaches 3 on the right side. So that limit is on the right side is right here, 2x plus 1. So as x approaches 3 on the right side, so we have 2x plus 1. So that gives us, we put a 3 in the place of x, we get 6 plus 1 is 7. So we also have to have the d of x as x approaches 3 on the left. And on the left, let's see what the left is. Let's look at the left is less than. So this is the function. It's the absolute value of x minus 10. So x is 3, so we put a 3 in. The absolute value of 3 minus 10 is a -7. The absolute value of -7 is 7. So that means the limit on the left is equal to the limit on the right. So that means the d of x, the two of them are the same. So that condition is true. Now, we have C condition is that the limit of the d of x as x approaches 3 is not equal to the d of x. So notice that at 3, the d, we could say at x at 3, let's put a 3 here instead of, is defined. So at 3, that we got a 5. And as it approaches 3, on the left 7, on the right is 7, so that's a 7. So 7 is not equal to 5, so therefore it's no. it's not continuous. And there's the explanation. So if you have this, give yourself a mark. If you have the right side, give yourself a mark. If you have the left side, give yourself a mark. And if you have come up to the both 7, so that's the mark for each of those. And if you said that the limit as it approaches 3 is not equal to the d of 3, give yourself a mark. And if you say no, give yourself a mark. So 5 marks for that question, 8 altogether. Okay, let's continue. Number 5, the g of x is equal to this piecewise function. And rather than go through each step here, is the g of x continuous at x equals -1? Again, we have to look at, is the g of, we're looking at -1. What is the g of -1? The g of -1 is equal to 6. So it's defined. The b part, we have to do as it approaches, x is approaching -1, and we'll go to the right side. So g of x, the right side, let's look up on top now and see approaching from the right side. So this is the left side, less than -1. This is the right side. So we go -5x plus 1. So x is -1. So that's 5 plus 1. That's a 6. And we look at the limit as the g of x approaches. This approaches, let's say, let's go -1 from the left side. So from the left side, let's see what the -1 from the left side. This is the left side, so that's a 4x squared plus 2. So we're going to put a -1 in there. -1 squared plus 1. -1 squared is 1. 4 times 1 is 4. Plus 2 gives us 6. So we have the limit on the right is 6. The limit on the left is 6. So that means that the limit of the g of x as x approaches -1 is 6. Because the left side equals the right side, 6 is 6. So the limit as g of x approaches -1 is 6. And we have to look at c, and the limit of the g of x as x approaches -1 is 6, and that equals to the g of -1, which is 6. So this is true, they're equal. So that means, is it continuous? The answer is yes. We went through the, so 1 mark for that, 2 marks for 6 here, and a mark saying they're equal, and yes, because it obeys the conditions. 5 marks altogether. Number 6, the t of x equals, this is a piecewise function where x is greater than or equal to -2. X is less than -2. So greater than -2 is on the right, less than -2 is on the left. So find the value of k for the t of x if it's continuous. So if it's continuous, that means it's equal to, we got to find the value of k, so that means that the left side is going to equal the right side at -2. So we're going to do -2. We're going to go to the right side, and then we're going to do the limit as the t of x approaches x on the left side. So the t of x, let's look at it as it approaches -2 on the right side. So the right side is greater than, so that's a kx plus 6. And that gives us, we're putting a -2 in, so it's k -2 plus 6. So it's -2k plus 6. That's the limit. With the value of k, we don't know yet, so, but we know that these two are going to equal. If it's continuous, the limit on the right equals the limit on the left. So let's look at the value of the limit on the left, or the expression on the left is, this is on the left, so this is 3x minus 4. So we have x times -2 minus 4. -6 minus 4 is -10. So the limit on the right equals the limit on the left. So that means that negative 2k plus 6 equals negative 10. Negative 2k equals negative 10 minus 6. That's a plus, bring it over, make a minus. Negative 2k is negative 16. Divide by negative 2k is 8. So when k is 8, this is the continuous function at the value of x equals negative 2. And there's 4 marks here, so if you get this one right, give yourself a mark. If you get a negative 10, give yourself a mark. If you make these two equal, give yourself a mark. If you get k is 8, give yourself a mark. 4 marks altogether, and that's a total of 9 for that page. And another one to do, number 7. Again, we have a piecewise function, and it says find the values of a and b if the f of x is continuous at negative 2 and 1. So it's continuous at 2 intervals. So we got a and b. So we got to find the values of a and b. So let's look at the limit of the f of x when x approaches, let's approach negative 2 on the right side. And so the limit, we're going to approach it on negative 2 on the right side. So the right side of negative 2 is greater than, so that's an x plus 5. So negative 2 plus 5 is 3. And now we have to look at the limit of the f of x as x approaches negative 2 on the left side. And we got a and b here, and we got a b here, so we got to do the find the value, the limit as it approaches negative 2. These two are going to equal. As it approaches 1, these two are going to equal. So that's 2 different sets, and that should come up with, as x approaches negative 2 on the left side, negative 2 on the left side is ax plus b, and x is negative 2, so it gives us negative 2a plus b, and that means that the limit on the left equals the limit on the right, so that means that a negative 2a plus b is equal to 3. So we have an equation in terms of a and b, so that means we have to do the continuity again, continuous at 1. So x is approaching 1 on the right side. So the f of x limit as x approaches 1 on the right side. So right here, 1 on the right side. This is the right side. So I should have ax plus 3b here. Ax plus 3b. Let's make this correct. So I put the function in here. So we're at 1. So it's a times 1 plus 3b. So a plus 3b. Now that's the limit approaching 1 on the right side. Now let's find the limit of the f of x as it approaches, x approaches 1 on the left side. And that limit, careful this time, I have to be careful, as approaches on the left side, this is the left side, so this is a squared plus b. And as it approaches a squared plus, or a squared, but I get a squared, x squared plus b. Oh, I looked at the a here, it says a squared plus b. So it's, no, it's x squared plus b. My mistake, approach on the left is x squared plus b. There's x squared plus b. Its approach is 1. So it's 1 minus b. So that means that the limit on the right equals the limit on the left if it's continuous. So that means a plus 3b is equal to 1 minus b. So a plus 3b plus b equals 1. So a plus 4b equals 1. So I have 2 equations. Equation 1. I have equation 2. So I'm going to solve this system of equations for a and b. So let's write down equation 1, write down equation 2, and we solve this. So to solve this, I'm going to do it by elimination. So that means this one is a negative 2, so I multiply this equation by 1. Negative 2a plus b equals 3. And elimination, so that's a negative 2, so I want a 2 in front of a. Multiply this equation by 2, I get 2a plus 8b equals 2. 2a plus 8b. I got, let's see, did I write it? I got to be careful here. 3a plus b. Okay, that's right. So multiply. I have negative 2 and 2, so that cancels out. So I get 9b equals 5. 9b equals 5. Just be careful. Yep, okay. So that means b divide is 5 over 9. Now I have the sub a back in. So let's sub a equals 5 over 9. Let's sub it into this equation right here. We could go into this one. Let's go into this one. Into negative 2a plus b equals 3. I can sub it into 1 or 2. So negative 2a plus 5 over 9 equals 3. I have a fraction, so I'm going to multiply by 9. So if I multiply by 9, I'll eliminate the fraction. Negative 18a plus 5 equals 27. Negative 18a equals 27 minus 5. Let's go up here. Negative 18a equals 5, that's 22. Divide by negative 18. A is in negative 22 over 18. So A is a negative 11 over 9. So we found the values of A and B. Again, I was hesitant just here. I was just making sure that I had this equation right and everything looks okay, and solving it out. So we have 8 marks. So give yourself a mark for that one, and getting the equation. A mark here for getting this one, and making them equal to 6 marks. If you solve it and you got B, and you solve it and you got A, 8 marks altogether for that page. So A is a negative 11 over 9, B is 5 over 9. To make the system continuous at the 2 points. Number 8, the h of x equals 4x plus 12 over x squared plus x minus 6. State the type of continuity of f of x that f of x has and where the continuity occurs. Well, the h of x is, we have a factor 4 on top, so we got 4 outside of x. 4 is the GCF, so take 4 out. And the bottom is a quadratic, so we got x and x. And factors of 6 to give me a 1 are 3 and 2. And it's a negative 6 product and a sum of 1, so it's a plus 3 minus 2. And that means that the h of x is equal to 4 over x plus 3. So that means we took out x plus 3. We canceled it out, so really we're taking out a negative 3. So if we take the negative 3 and we cancel these out. So this is x, my mistake. Gotta be careful. We took out the x minus 3. I never cancel them out. And we have a x minus 2. So we cancel out the x plus 3. So we're canceling out x equals 3. So we put the negative 3 back in and see what value we're going to get for our function. So that's 4 over negative 5. So that gives us a negative 4 over 5. So it's discontinuous at x, it's a whole. So it's a whole at x is negative 3 and negative 4 over 5. So there's a whole in this graph right here, because it's discontinuous at x is -3. Now we also have 4 over x minus 2. So when x minus 2 equals 0, x is 2. We cannot have our denominator. We put 2 in the place of x. We get 2 over 2. Sorry, 4 divided by 2 minus 2. So it's 4 over 0. So that's undefined. So that means it's discontinuous. It's not continuous. Discontinuous or not continuous at 2. So that means that the vertical asymptote is at x equals 2. So it's discontinuous at 2. And so this one is a removable, I didn't name it. This is a removable discontinuity because you're removing x plus 3. This is a removable discontinuity. More eyes here. And this one is an asymptotic because it's an asymptote, a vertical asymptote. This is an asymptotic discontinuity. So, if you have 8 marks for this, so if you factor this correctly and you cancel that down, give yourself a mark. If you made it discontinuous at x is -3 and found this point here, that's 4 marks here. If you made it found out that it was the vertical asymptote at 2, come up with 2, plugged it in and got it undefined, and you named it asymptotic discontinuity, there's 4 marks here. So 4 marks for the first one, removable, 4 marks for asymptotic, and 8 marks in total. So hopefully everything went well, except for a few little errors that I normally make when I present. Try to correct myself. I always make a few errors, but I try to correct myself. So the total for this review, which is the last video on this unit of limits and continuity, the total is 33. Hopefully you have 33. If you don't, divide 33 into the numerator, get a decimal, move your decimal 2 places to the right to get your percent. So this is the last video on limits and continuity. And if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.